The possibilities of 3D printing seem to be endless. At the cutting edge is Jack Buth, professor of mechanical engineering at Carnegie Mellon University. He argues that in the next 5 years, metal 3D printing will provide key advances that could revolutionize the fields of aerospace defense, alternative energy, and more. Jack Buth, welcome to the program.
Oh, thank you.
So when I think of 3D printing, I think of something that's actually being pressed from nothing, right? And for me, I've seen plastics and powders, metal. I think of huge molten lava that's kind of constructed in a foundry. How did you get these pieces to happen?
Yeah, so I have a couple of parts here. The way that the metal parts are fabricated, it's very similar to the way that polymer parts are fabricated in the maker machines. A lot of people are acquainted with those. Essentially, you take a three-dimensional shape and you divide it into very, very thin layers. And that three-dimensional shape is built up one layer at a time. And what's different with the metal processes is you're building up metal layers, and that's being done by taking a laser beam or an electron beam and moving that over powder and locally fusing the powder to create a two-dimensional shape, which is then used to build the three-dimensional shape, again, one layer at a time.
So you are melting, so to speak, at whatever temperature that laser is, but it's not the type of metal work that we're all familiar with.
Yeah, in fact, this is done at a very, very small scale. We're talking about a melt pool. Think of like a welding, a pool that you have when you're doing welding. It's a fraction of a millimeter in width. And that melt pool is moving back and forth across to actually fill in a two-dimensional shape of a layer.
All right, so let's take a look at one of the objects you have here. How long does it take to create something like that?
So something like this is on one of our machines is about 2 to 3 hours. Now you can gain some productivity by having multiple parts within the build volumes.
Well, from the outside, it looks like it could be blades of a fan or something, but when you turn
this
it
is
around,
an impeller, is what they call it, right? And in fact, probably your hair dryer has an impeller in it. Impellers are used to move air. Yeah. And so if you look at it from the outside, you will say, well, that looks like a traditional design. We use this in some of our training courses. With 3D printing, you can embed three-dimensional cellular meshes. And those cellular meshes, it's like a honeycomb for bees' honeycomb in that it's strong and it's stiff, but it's very light. And so they may look like they're solid on the outside, but it's really just a shell, and then you've designed in a three-dimensional cellular mesh on the inside to give you the properties that you want.
So you guys, of course, all good engineers have to come up with top 10 lists of where this could change the world. And I noticed high-performance racing cars was on top of this list. How is that possible?
The original adopters of this, in fact, the lead adopters are the aerospace industry, particularly the jet engine companies. GE is leading the way there. But over the past, in fact, originally it was aerospace, and then also medical implants, knee implants, hip implants, making customized implants. But over the past year, things have broadened substantially. So we see every type of company that makes metal parts is now interested in 3D printing. And the automotive industry is really the next one to start adopting the techniques.
Because the lighter the car, the more fuel efficient it is.
Well, usually there's a cost advantage if by using 3D printing, you can create a part that you can't make by traditional processes, particularly if it's something that increases the performance of the overall system. Mm-hmm. So an example of that would be GE has created a fuel nozzle for their jet engines. The fuel nozzle is used to be 20 parts, now it's one part. It's one 3D printed part. But the key point is by redesigning that fuel nozzle, they made the whole engine more efficient. And in the jet engine industry, making a jet engine more efficient is the key thing to selling it.
When you said hip implants and knee implants, so there is a future not too far away where if you get one of those replacements, it could be customized to exactly what you need versus I'm getting this part put in.
Correct. So you could have a customized implant. And another thing that could be customized is the fixturing that's used to hold the bones in place, for instance, while the implant is being installed. And if that's customized, then it's much more likely that the surgery is going to be effective and successful.
We're not going to have 3D metal printers in our garages anytime soon. I mean, this still seems industrial scale. You still need a bit of infrastructure, but think 5 years out, 10 years out.
3D printing of metals will be all over the place, except one caveat to that is that you're dealing with very fine powders, and so you have to be very careful. Some of those powders can be fire hazards or explosion hazards, and it's not good for your lungs, so they're inhalation hazards. So these are industrial processes, but it's very realistic that you could have For instance, if you go to an automotive parts store, you could order a part, and there would be some maybe regional place where they can 3D print your part and get it to you by the end of the day, for instance.
Wow, that's fantastic. So is there an industry that you see that won't be affected by this? I mean, it's basically if it has metal in it, there's a chance it can be customized.
Yeah, so at our next manufacturing consortium, our next manufacturing center at Carnegie Mellon, we have a number of companies that are supporting our research. And from everything we see, every company that makes metal components is at least looking at 3D printing. And the key issue is not to just look at the processes as they exist now, but to, again, look out 5 or 10 years and see where they're going to be. And each of those companies, and some of them may conclude, well, it's not really for the products that we make. Some may conclude, well, not now, but maybe in 5 years. But everybody's taking a very close look at it.
So, you know, one of the questions you always get is this mix between technology and jobs. And as these new technologies come online, I'm thinking that the person who might be designing the old-fashioned fan that went into the hairdryer,
the one that looks like this, right?
The one that looked like that, from a solid part, that machine is maybe going to get replaced. But the worker that goes with that machine now has to learn kind of a different set of skills.
So it's true that 3D printing can replace some things like what's called CNC machining, which is numerically controlled machining. You go, well, the person that does the CNC machining may go out of business. But it ends up that the 3D printed part also has to be post-processed, typically. So there's usually some type of surface finish work that has to be done on these parts. There's heat treating, there's something called hipping, which lets you close up pores in the parts. And it's just learning to, say, work on a 3D printed part in a post-processing mode as opposed to creating the entire part from scratch.
All right, Jack Buth from Carnegie Mellon, thanks so much for joining us.
Okay, thank you.